Welcome to all. Today's class I am going to give you shortcut for finding moment of inertia about centroidal axis, means both xx and yy for, I write what all covered, I write here, for, I write for here, for, okay, I'll start from here, one by one. Symmetrical I section, asymmetric or I call unsymmetrical I section, but conditions are there. These already over. Now, furthermore, hollow rectangular section and hollow circular section. Now, write all explanation given in the class. You should write all the explanation. I cannot write each and everything here. Those who want to understand correctly, everything you have to write. See, first of all, remember why it is useful. These all required for strength of materials. In strength of materials, bending stress chapter or shear stress distribution and columns, torsion you require only circular section, there you require polar moment of inertia, leave it. Even for columns and some more chapters later in structural analysis, you require moment of inertia about centroidal axis for most popular questions in examinations, any examination, and some of them are also practical oriented. Symmetrical I section, I call unsymmetrical I section, hollow rectangular and hollow circular. These two new addition. The last class I considered these two. Along with these two, I will give this also. See, still we are not gone for circular part in moment of inertia, numericals. Right now, we will consider now. See, first of all, make a note, what all I tell. Symmetrical I section, you write this sketch. See, symmetrical about both xx and yy. See, xx, yy, both are symmetrical. Now, if it is symmetrical, see what happens. First of all, dimensions wise. See, yy. Whatever is this width here, this is half, this is half. Whatever is this depth here, this is half, this is half. So, if I call this as yy, yy, I will do one thing now. This width I will call b. I will simply call b now. B. Total depth I will call d. Capital D. This one. Then symmetrical means, see, this should be equal to this one. These are equal. This width should be equal to this width. Then yy will be at what distance? Your yy will be at b by 2 from here. See, yy. You write second time. First you write the sketch. Second time write here. This also is b by 2. If this is d, both will be d by 2, d by 2. xx, d by 2, d by 2. That means symmetrical about both xx and yy. So x bar and y bar both are not required. You don't have to bother about x bar calculation and y bar calculation, because when symmetry is there, directly you can locate both the axes. Write all those statements. Further, I will give later. This all you have to enter somewhere. Come to unsymmetrical I section. I use the word unsymmetrical. Unsymmetrical means not that random. See, earlier I considered I section, if you remember. Something like this all. These all imagination, that's all. Unsymmetrical I section is, see, this is B, I will call, this is yy, see. I will call yy here, yy here. Imagine the top width I will call b1, b1. Bottom width I will call, this is yy, space problem here, okay. Yy, so it's the space problem, okay. Bottom width I will call b2, b2. Then b1 and b2 need not be equal. This thickness also need not be equal. But very important, this projection should be equal to this projection. this projection should be equal to this projection. So if this is B1, see, you can see whatever is this projection here is this projection at the top. Same way, projection of flange at the bottom beyond web, both side equal. So this is axis of symmetry. So therefore, x bar not required directly. How much? If this is B1, this will be equal to, directly without calculating, B1 by 2, B1 by 2. Here, if it is B2, directly B2 by 2 and B2 by 2. Later, I will not use B1, B2. This is for explanation. I may use some other symbol later. Okay. If this is B2, B2 by 2, B2 by 2. Now here, so x bar not required, but y bar is required. See, y bar required. See, if this is total depth D, I am not marking D here. This is not equal to this one. So y bar required. Then hollow rectangle section. See, now this is equal to this, you can make out here. See, now this thickness I will call it T1. If that is T1, this also should be same T1. Both should be equal. And this thickness I will call T2. This should be T2. Of course, T1, T2 both can be equal. That is not required. What you want is, see this all you are right, T1. This thickness should be equal to this thickness. This thickness should be equal to this thickness. This is empty portion. See, rectangle here, hollow rectangle. Then you don't have to worry. See, xx and yy symmetrical about both xx and yy. Again, x bar, y bar, both are not required. You write somewhere here, if this is B, each will be, I will put T1 here, space problem. See, this is T1, okay. If this is B, both will be B by 2 and B by 2. And if the total depth is D, this all you have to mark neatly. If the total depth is D, both will be equal to D by 2, D by 2. D by 2 and D by 2. See, there is no rule that this thickness should be equal to this thickness. No, symmetry means this thickness should be equal to this thickness should be equal to this thickness. Sometimes they can give all same thickness. Okay, well and good. Again, x bar, y bar not required. Hollow circular section, that is very simple to understand. See, this is hollow circular section, or sometimes they call a pipe section. Pipe section. Here, not required. That's all. Sketch only will tell you symmetrical about x, x, y, y. Again, here also, see, same statement here. X bar, y bar not required. Okay, now I will tell you systematically, one by one. See, these two last I will tell. First, these two I sections, which already we covered last time. Okay, I'll prepare the schedule for you. Start now. First, the most important, symmetrical I section, lot of application. See, you do one thing, write BF, breadth of flange. You write what all I tell. BF is the breadth of flange. You should write. Then, capital D is the full depth of I section. In steel structures, it is called H, but here you will call D. Okay, capital D. Then, capital D or small d, okay, capital D will do. No. Symbol is not a problem. TF, see, both are equal. TF is thickness of each flange. You should write it. And TW, thickness of web. DW, depth of web. So remember now, the depth of web equal to, I won't, see, actually I don't have right here. Why? Okay, I make, remember now here, dw equal to, very important, see, total depth d, I won't explain again and again, minus 2 times of thickness of flange. Okay, again I will not tell. And one more thing, I will explain everything. Every time I cannot tell. It is your responsibility to write everything or go through this repeatedly till you understand. I will not tell because lengthy statements are there. Okay, now start. Now Ixx, see xx here, if this is d by 2, d by 2, y here, bb. Therefore, make a note, x bar and y bar both are not required because, why reason? Both are not required because xx and yy both are axis of symmetry. You should write here, see, xx and yy both are axis of symmetry. Directly you locate. No calculation. Now, what you do is, first Ixx, Iyy later. See what principle is for Ixx. It is not valid for Iyy. So many people, they misunderstand that one. See, when you want Ixx, see here xx. See, class, write everything. First you consider a full rectangle. See, full rectangle. Write what all I tell you should write. Consider a full rectangle that is complete boundary. Right here, complete boundary. See, that is, see, dotted line here. Full rectangle. So, see, full width here, BF, full depth D. Okay, this is full rectangle. That is, see here, full. See how my hand is moving. This is the rectangle. Ignore about this portion. No web, no flange, nothing. Full rectangle. BF width D. Ixx equal to BF into D cube by 12. Why? Parallel side into perpendicular side cube by 12. Now, actually, the I section, it is not a full rectangle. See, there are two empty portions here. The empty portion, two empty portions. See here, I have put dot. See, for understanding here, see, dot, 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 dot. There are two empty portions here. So from this full rectangle, you subtract these two empty portions. So I used to sign minus here. See, so you write here, your actual I section is, you should write here, your actual I section is full rectangle minus two empty rectangles. See, one empty rectangle here, one more empty rectangle here. Okay, now you don't require separately the two. See, each empty rectangle width equal to BF minus TW divided by 2. Not required because when you do about XX, this distance we are not, see, this empty portion here, this actually is your thickness of web. So do one thing, this empty rectangle, see, this empty rectangle and this empty rectangle together, two empty rectangles. You write total sum of the width of the two empty rectangles. The two empty rectangles will have a width of, see here, full is BF, TW is still there, empty portion is this one and this one, this one and this one. The two empty portion equal to BF minus TW. If this is not clear, better not study anything. And DW is the empty depth. The empty depth is nothing but depth of web, DW. DW equal to whatever capital DC. When I put empty, see here, I raised it here. The MDW is total D minus TF 2 times. Okay, now I about this axis equal to, once again, BD cube by 12. You do one thing, both the rectangles, see right here, instead of, don't consider two rectangles. The two rectangles merge the two rectangles. When you merge the two rectangles, you get a rectangle of width total BF minus TW into DW cube divided by 12. Therefore, for the actual given I section, final answer for the given I section, Ixx is BF into D cube by 12 minus BF minus TW into DW cube divided by 12. Or in the class I will tell words now. See, See here, don't see there, see here only. Now right there, after everything, he explained with respect to original sketch. See here, I about x-axis, outer BD cube by 12. See, outer B means BF, outer B D cube by 12 minus empty BD cube by 12. Empty width is, there are two empty portion or see two empty portion. The two empty portion together equal to this total BF minus TW. So outer BD cube by 12 minus empty BD cube. Empty depth is DW only. See, outer BD cube by 12 minus empty means two empty are there. Single empty is what? Join those two. See, these two together you make a single empty. So this net total or net width of these two. So BF minus TW, empty B into DW cube divided by 12. That's all. I cannot explain further. If this is not clear, then you find moment of inertia the way I told in the last class. How? Ig plus A square, Ig plus A square, Ig plus A square. Then find that way. If still it is not clear, I am helpless. This is regarding I about XX. Now, immediately I will tell I about YY. Now, this theory is not applicable for I about YY. Reason is there. See, because one note you write here. When you find I about XX, your full BD, full outer rectangle for full rectangle and empty rectangle, both are symmetrical about XX. But for YY, it is not that way. See, for YY, the two empty portions are symmetrical means symmetrical only, not word symmetrical. See, for when you do I about XX, for the full rectangle, XX is the axis, and empty also, XX is centroidal axis. But when you consider IYY, for the full rectangle, YY is the axis, but for empty, YY comes here. It is not here. So this outer BD cube by 12 minus empty BD cube by 12. Remember that way. See, rectangle moment of inertia is BD cube by 12. Remember, parallel side into perpendicular cube by 12. So what I told, simple words, I will give example for you. Outer BD cube by 12 minus net empty BD cube by 12 is valid only for XX. Okay, now YY is very simple. See now I want I about YY. This is very simple because see, I about YY. Very simple because see, when you want IYY, see, this is rectangle. Divide into parts. Another rectangle here. Now one more rectangle here. Okay, now symmetrical. YY symmetrical. Okay, now. Okay, scale. Don't bother about too much about those things. This is actually time consuming. Okay. Little more. Okay. Okay, now see here. What will happen is your YY axis comes here. YY. Now you make a note here. For YY axis, see, centroid of this rectangle, centroid of this, and centroid of this all will coincide. So when you apply parallax theorem, I equal to what? I about YY equal to, see, IG plus AH square. That H will become 0 for all three parts. All three parts. See, your centroid of each component lies here. See here, your empty theory will not work out. Therefore, see, this is your breadth of flange. This is thickness of flange. This also thickness of flange. This also breadth of flange. This is depth of web. You know how to find depth of web? Depth of total is D. See, if total is D, depth of web equal to how much? D minus 2 into thickness of flange. This is TW. So therefore, for this one, your Ig equal to, see, Ig equal to Tf into Bf cube by 12. This about Yy. About Yy. Ig is Tf into Bf cube divided by 12. For this also, your Ig equal to Tf into Bf cube divided by 12. For this one, Ig equal to, for this portion, see, for this portion, I'll write here, your Ig equal to dW into Tw cube divided by 12. And for all of them, when you continue parallax theorem, Ig plus A square H equal to 0. Therefore, right here, directly, I about Yy equal to, I about Yy equal to directly, start. See, you do like a normal rectangle, Yy, Tf into Bf cube by 12, Tf into Bf cube divided by 12. See, there is one more identical part here, multiplied by 2. 2 because 1 here, plus dW into Tw cube divided by 12 over. Or I will tell words, class. When you want Yy, you apply parallel axis theorem, but do not waste time. When you apply parallax theorem, Ig plus A square, H becomes 0 because centroid of all three components lies in Yy. When H becomes 0, Ig itself is moment of inertia. When Ig itself is moment of inertia, you take your hand here and write this width into this cube by 12. See, upper flange, Tf into Bf cube by 12, multiply by 2 for lower flange, and dW into Tw cube by 12. That's all, you get the answer. Over. Now, I will give examples for symmetrical isection, then unsymmetrical isection. Now, symmetrical isection examples. See, right here, examples for symmetrical isection. Example 1. See, all dimension millimeter, 216, 12, 250. Understood, this also 200 by 16. Actually, note, this is the question number 18 in the last class where I explained by parallax theorem. You make a note. And this is next by words I have given. I section 300 by 400 with the 12 mm thick flanges and 10 mm thick web. This is question number 19 in the last class, which I gave as exercise for you. Exercise for you, but brief answer, answer I have given. Okay, now make a note. Last class we wrote the section, then some statements all you wrote, applied parallax theorem, nothing required. See here, I will solve this one. Question is what? Today's class, every numerical example, question is you write, find moment of inertia about centroidal axis. I won't write it. See, this question. Once actually, sketch also not required. You can see here only, but still, you see, when this is given here, make a neat sketch here. See, when you want I about xx, this way, see, divide into parts, no problem. Actually, dividing into part is not required when you do I about xx axis. Okay, this is a section. Okay, divide into parts. Correct, no? Okay, somewhat okay. Don't worry about these things all. Only there are people who will tell slightly shifted this side, that's all, no problem. See, right here, width. All millimeter, all dimensions in millimeter, how much it is? 200. Then, this thickness you write here, 16. This thickness is 16. Now, here, this depth given, whatever given enter here. If this is given, this you have to calculate. I should not tell how to calculate. 250 plus 16 plus 16 is 282 calculated value. Okay. Then this thickness also write. How much? 12. This width is not required. Same 200. Okay, now see what to do. Mark x-axis axis directly. How much is one? This is 282 means half. 141, 141 directly. Mark y axis. How much here? Both y axis. Both are 100, 100. Half of 200, half of 200. That's all. Now see correctly what I am doing. I about xx. What all I tell right. First, full bit. See, xx means I told parallel side first. Cube is always for perpendicular side. This side thousands of times I told. See, xx. Full rectangle. 200 by 282. 200 by 282 cube divided by 12. This is your outer BD cube. See, for full BD cube, see, full rectangle. Subtract, see, correctly here. This is 200. We want net, there is empty portion here, empty here. We want the total empty. The total empty is undoubtedly from 200 subtract 12. 200 subtract 12. Okay, here only. See, this is 200. 12 is still there. Empty is, see, this is empty portion. 200 minus 12 into empty depth is here into 250 cube divided by 12 over. That's all. Calculate the answer. See what answer you got last time. It should give same answer this time also. Okay. Then I about yy. When you want I about yy, you first make a note. This outer BD cube minus empty BD cube is not applicable to yy because for empty portions, its own axis is outside. So you don't apply the trick. That the trick of outer full BD cube by 12 minus empty BD cube by 12, that is only for xx. For yy, what you do is no parallax theorem, nothing. See, yy we want 3 rectangles, only ig. See, 16 into 200 cube by 12, that's all. Only ig. 16 into 200 cube by 12, that's all. Multiplied by 2 because plus area into 0 square. Multiply by 2 for these two plus for this one, see, this rectangle. 250 into 12 cube by 12. 250 into 12 cube by 12. No minus here, plus actually, because when you do ixx, outer minus empty. When you do iyy, you are adding the 3. Don't put minus here, over. Calculate the answer. See what answer you got last time. Same answer will come. Okay, that's all. Now, I'll remove this one now. I'll go for second example. Which I saw last time. See, this example. That is this one. Example 2. Write the section. See. Scale is not required. See, what all they given? They told I section 300 by 400 means this is 300 width. 400 is the full depth. Be careful. 400 is full depth. I told you. 400. Then the two flanges are 12 mm thickness. 12, 12. If that is 12, this you require to calculate. From 400, subtract 12 2 times 24, 376. This you have to calculate. Okay. This thickness is 10 mm web. 10 over. That's all. See. XX. YY. If you want to mark distances for axis, total 400, each half of that one 200, 200. Total 300, each half is 150, 150. Now see, I about xx. Last time I will tell you now. First, full I about xx. Full BD cube by 12. Outer BD cube by 12. 300 into 400 cube. 300 into 400 cube divided by 12. Okay. This is outer. Then subtract 2 empty portion. I want empty width. See, this 300. This width and this width total I want. Total of these two width is 300 minus 10. Bracket required. 300 minus 10 into empty depth is 376 cube divided by 12. That's all. Calculate, you get the answer. Then IYY. I told very easily for YY. What you do? Don't apply parallax theorem because centroid of each component lies in YY. Actually, IG plus A square, H is 0. Only IG. See here. 12 into 300 cube by 12. 12 into 300 cube by 12. That is I for this rectangle into 2 plus for this rectangle 376 into 10 cube by 12. 10 cube by 12. That's all. Calculate the answer. Actually, last time I gave answer by shortcut only. Calculate. This will complete for symmetrical I section. Now I will tell you if it's unsymmetrical. Where actually you should be very careful. Now when you do I about xx, IG plus A square is there. There's a shortcut is there. I will tell you shortcut. I will write and explain and then start. Now, for unsymmetrical I section, see what all I tell you have to write. Don't be lazy. See, tilted here. Okay. An I section where YY is, I told you, axis of symmetry. See, therefore, axis of symmetry. Therefore, what? No need of x bar calculation. This I told you. X bar calculation is not there. Only, okay, then, but xx to be located using y bar calculation. That's all I told you for you earlier. Now, first, see, come here. Consider Ixx. To get Ixx, first you have to locate xx. For that you require y bar from reference axis. We will do one thing from AB. See, what I am telling is when reference axis at the bottom. Same theory, even if you take reference at the top, no problem. Okay, y bar, formula right. Then locate xx. Note, while finding y bar, note down y1, y2, y3. Note down that y1, y2, y3. Important. You should note down that y1, y2, y3. Required later. Bar shortcut method. Okay, now come here. Okay. See, note down one. Then after getting y bar, locate xx. Xx. See, I don't know. It may come above or it may come below. See, if I take reference here, figure 1, figure 2, figure 3. See, this is your G1. This all I told you. G1, G2, G3, Y1, Y2, Y3. That you require. I will tell you why. Then, see, Ixx equal. I don't know where is xx. See, what I am explaining. Anywhere xx is there. Okay, see, xx somewhere. I for this one. I about its own axis. Ig1 plus area into this distance square. See, wherever xs is there, see, this is your y bar. So, this distance from centroid to xx is y bar minus y1 square. Then, for second one, I about its own axis plus area into this distance square is, see, y bar minus y2 square. When you do for G3 about this axis, from here to here axis will be y3 minus y bar square. But do one thing, you take, see, for these, if the axis comes here, for these two, it will be y bar minus y1 and y bar minus y2. But for the third one, it is y3 minus y bar. But no problem, because you are squaring it. Since you are squaring it, see, so therefore, ig plus a square, ig plus a square, ig plus a square, your h1 equal to y bar minus y1, see, mode. Means no sign. You write whatever you got. Because you are squaring it, see here also, h2 equal to y bar minus y2, h3 equal to y bar minus y3. See, actually h3 is y3 minus y bar. You make a note here. Actually, here as per this sketch, h1 is correct, y bar minus y1. h2 is correct, if the axis comes here, y bar minus y2. But h3 equal to, from here to here is y3 minus y bar. But you are squaring it, therefore no problem. So for all the three, your h square will be y bar minus respective y. So remember, that's all. Furthermore, I won't tell because it's a crude method, shortcut method. Therefore, remember, when you find ixx, see, for ixx, very important, for ixx, what you write? Write ixx equal to, for each part, ig plus area into y bar minus y bar is red color, see, y bar is red color, y bar minus y for that part, its whole square. Sometimes it will become y bar minus y for that part, or if it's other side, it is y for that part minus y bar, but you are squaring it, therefore no problem. Okay, now I will explain, it will be more clear when I go to numerical. Okay, now after that one, I about yy. Oh, no problem, because when you go for yy, right here, it is same as that for symmetrical I section. Because your G1, G2, G3 all lies in YY. So symmetrical, last time symmetrical I section, symmetry about YY and XX both. Their XX shortcut, outer BD cube minus empty BD cube. Here, for XX, little work is there. But for YY, same as that one. What? Only IG. That is, only IG for each part. That's all. Furthermore, I won't explain. Those who can understand with the concept, they will understand. People who do not want to worry too much, they will tell, sir, we want application. Yes, application, I will tell systematically now. Because finally what counts? Example is the most important. Okay, example 1 minute, I forgot. See, this example 1 is same as your example 16 in the last class. You make a note here. This example 1 is, this is same as considered, same as question 16 in last class. So last class, I have not got the answer. I won't get this time also. So I explained systematically. Now shortcut, see here. 250 by 18. This is 18, not 16. If this is 18, this is 338. Oh, see, chance of making mistake. No, 338. Okay, done. Then 16 by 300. 16 by 300. 150 by 20. Okay, write whatever you got. 150 by 20. First one thing. Okay, now I will remove this one. I want space now. See, I will write everything here. Example over. Okay. Need sketch you write. Now, I'll remove this one now. See, first, note, I told you YY is symmetrical axis. YY is axis of symmetry. This will mark later. So, IXX we want. Therefore, XX to be located using Y bar calculation. Okay, take reference. I will explain for bottom edge. See, take bottom edge reference. Say AB here, AB. Y bar calculation. See, Y bar we will calculate, reference is AB. That is bottom edge. Bottom edge. Okay, start directly. See, what you do is, you write Y bar equal, don't waste time now. Y bar from AB. See, from AB is important. From AB equal to formula you write. A1 Y1 plus A2 Y2 plus A3 Y. Okay, I'll write this time. A1 Y1 plus A2 Y2, I use black color, plus A3 Y3 divided by total area equal to C. A1 150 into 20. 20 is A1 into Y1. Y1 is 20 by 2. I will put 10 here because you require. This is 20 by 2. That's how you got 10. Now numbers are, that's why I told. You write the answer here, or you can do one thing right here. 20 by 2. 20 by 2, that is equal to 10. Okay, plus A2. 16 by 300. 300 into Y2. 20 plus half of 300. 20 plus 300 by 2. That answer is equal to 20, 150 plus 20 is 150 plus 20, 170 you require. Plus A3, 250 by 18. 18 into Y3, 338 minus 18 by 2. 338 minus 18 by 2. See, that answer you require, this answer you require equal to 338 minus 18 by 2. Minus 18 by 2 is 338 minus 18 divided by 2 is 329. 329, very important. 329 divided by A1, 150 into 20 plus A2, 16 into 300 plus A3, 250 into 18. Calculate the answer. I noted down the answer. It is coming 189. See, very important. 189 point. I'll write here. See, here write. Equal to 189.146. Now remember, same Y bar you have to use everywhere now. 189.146 means, see, 20 plus 150 is 170. So little above. That you require for location. Okay, locate here. XX. Now very, very important. This is your Y bar. Very, very important. Right here. This is your Y bar equal to 189.146. This distance you write only for understanding purpose. Don't use it. Should not use it now. That will be from 338 subtract, it will come 148.854. No. You should use this number now. For all the three, this Y bar you have to use. See your Y1, Y2, Y3 are all from AB. See, Y1, Y2, Y3 are all from AB, and Y bar also is from AB. Now see, IXX. Fast I will tell. IXX. Again, remember, what is the principle? I equal to IG plus A square. A into H square. Okay, start. IXX. I write here. Start here. This you write. 150, see, you don't have to struggle when you do distance square. See, this is how much, nothing required now. See, Ixx, Ig, 150 into 20 cube by 12. I am doing the order now, 20 cube by 12 plus 150 into 20 is the area into, this is for figure number 1, without seeing anywhere, y bar, see, 189.146 minus y1 is 10, minus 10 whole square, that's all. See, Ig plus A square, I told, for every part, your H will be y bar minus y for that during y bar calculation. During y bar calculation, what y is there, that's all. See, over. For figure number 1 over figure number 2 plus second one. This is for figure number 1. Figure number 2. See, first Ig directly 16 into 300 cube by 12. 16 into 300 cube by 12 Ig plus area 16 into 300 into, without bothering, y bar 189.146 minus y2. y2 is 170, that's all. Minus 170 whole square. I'll check the camera once, safer side. Should not go beyond. Okay, no problem. I thought power gone, but power came back immediately. Okay, now figure 2 over plus now figure 3. See, that figure 2, figure 3. Start. First Ig 250 into 18 cube by 12. This will, see, this will, what the advantage here is, you don't have to worry. See, most difficult is the H square. You don't have to worry. Plus area 250 into 18 is the area into, actually see, from centroid of the component, nothing required. Y bar, what y bar you got here, your main answer, y bar minus y3, 189.146 minus y3 is, where is y3? Oh, 329, see, minus 329. Actually it is 329 minus y bar, no problem, because you are squaring. This is for figure number 3. Okay, full over. Calculate the answer, you get it. Now, what answer you got last time should correctly tally. Okay, I will explain once again now. Y bar, see, once you decide y bar from where you are considering, throughout moment of inertia, use the same y bar. Don't go to other y bar. You can do it from top also. Then throughout you have to use same y bar. See, A1, Y1, A1, Y1, 20 by 2, Y2, 20 plus 300 by 2, Y3, 338 minus 18 by 2. That you note down. Then I about XX, see, without seeing. 150 into 20 cube by 12 plus 150 into 20 into y bar minus y1 square. 16 into 300 cube by 12 plus 16 into 300 into y bar minus y2 square. 250 into 18 cube by 12 plus 250 into 18 area into y bar minus y3 square. It will take care of everything. Now, I about yy. Just now I told, see, when now once this is over now, I about yy. Very fast over, see. I about yy, red color. I about yy. How much? First mark yy. Oh, it is axis of symmetry. Your yy is axis of symmetry. Therefore, same way as, therefore, Iyy, same way as symmetrical I section. Last time, symmetrical I section. Therefore, IYY equal to directly, see here, but into 2 you can't make. IYY, 18 into 250 cube by 12, 18 into 250 cube by 12, that's all, IG plus 0 square, plus 300 into 16 cube by 12. Last time, for this one, you multiplied by 2, don't multiply by 2. Once again you have to do it here, 20 into 150 cube by 12. 20 into 150 cube divided by 12. Get the answer. That's all. That is for IYY. Now, see, what you do is, last class, I gave an exercise for you. No exercise. I solved fully. Question number I see you, unsymmetric section. One more example to make clear, to make pakka clear, no confusion for that purpose. These are all shortcut. Question, where is the question? Oh, I have to note down from the YouTube. One sometime. Now, example 2, so that you get more practice. This is same as question 19 last time, but this time I will explain briefly. Briefly I will explain. Very briefly I will explain. See, this is 180. Dimension given. Question given here. This is a given question. So start. 125 by 12.5. 125, 12.5. 180, 10. 180, 10. Thickness 8. This time total 300 given. Therefore, this depth is 300 minus sum of these two. You get the answer. Okay, over. Now, y bar I not wrote it down. Okay, I will do one thing. Little more I will write and then I will explain. I already told, briefly I am telling, see, sketch over. Start. Y1, half of 10, 5. Y2, 10 plus 277.5 by 2. Answer is 148. All explained, not once, thousands times. This answer. Y3, from here, 10 plus 277.5 plus 12.5 by 2, or 300 minus 12.5 by 2. Y3. Substitute, get y bar. A1, y1, A2, y2, A3, y3. Divide by total area, you will get y bar. Locate. 148.984. See, y2 is 148. So it will come little below this time. See, it will come below x axis. Our important is this y bar. Remember, this y bar is the most important for us. 142.984. This one you write later. You write it. It is not required. From 300 subtract, because this y1, y2, y3 all are from AB. This y bar is from AB. Now in shortcut, when you write y bar minus y square, you should use same y bar. Okay, start. IXX. 180 into 10 cube by 12 plus area into 142.984 minus 5 whole square. I wrote here. Second one, 8 into 277.5 cube by 12 plus 8 into 277.5 area into y bar minus y2 square. That's all. See, no thinking required. Okay, next. Lastly, 125 into 12.5 cube by 12 plus 125 into 12.5 area into 142.98 for y bar minus 293.75. Actually, it is 293.75 minus, but okay, negative square is there. So 142.984 minus 293.75 square. Otherwise, see, you start I about its own axis. I want this distance square. Then here, see, careful, this distance required. No struggling. For this one, y bar minus y1 square. For this one, y bar minus y2 square. For this one, y bar minus y3 square. That is Ix. Iyy, you write. Why? Directly, see, mark y. This is very easy because why? Symmetry is there. 12.5 into 125 cube by 12, 277.5 into 8 cube by 12, 10 into 180 cube by 12. I wrote the answer. Okay, this will complete what I considered in the last class. Now, since we are going for shortcut for hollow rectangular section and hollow circular section, you require in strength of materials. I will complete today only so that later you can use this shortcut class whenever you require it. Okay, I will write and explain. Hollow rectangular section you require later, but remember it should be symmetrical about both xx and yy. Otherwise you can't apply shortcut. Make a note. This is a condition. If this condition is not satisfied, then you have to go to parallax theorem. That we will cover later. See, later I may give you 20 mm here and 30 mm here, 25 here, 15 here. That all I will cover later. But usually when they give a hollow rectangular section, write a note here. Some people call this as box section. Some people call this box section. Okay. In such cases, very fast you can do. See, B and D, width and depth. You should, what all I dictate you ought write. Full width and full depth. T1 is upper side thickness, upper and lower side thickness. Both should be equal. See, if this is T1, this should be T1. And if this is T2, this should be T2. If they are different or these are different, then you cannot apply shortcut. Make a note, T2. Okay, now, this is a given section. Right here. No need of x bar and y bar because x, x, y, y both are axis of symmetry. B, D, x, x, y, y, d by 2, d by 2, b by 2, b by 2. Okay, now what you do is B and D class, B and D are outer dimensions, outer. See, full width and full depth. Inside here, see, this is empty portion. B dash and D dash are dimensions for empty portion. See, empty, see, B is the outer width, D is the outer depth. B dash is the empty width, D dash is empty width or inner width and inner depth. Surely, see, your B dash equal to B, see here, your B dash equal to, refer original diagram, your B dash, you don't write thickness here, see, your B dash equal to B minus 2 times thickness, 2T2, and your D dash equal to D minus 2 times thickness T1. You write all this. Now, very, very easy. Area equal to BD minus B dash D dash over I about XX. See, BD cube by 12 minus B dash D dash cube by 12. Very simple. IYY. D into B cube by 12 minus D dash into B dash cube by 12. Now, for this, all the three, I will give words. Area. Outer BD minus empty, outer width into depth minus empty width into depth. Now, IXX. Outer width into outer depth cube by 12 minus empty width into empty depth cube by 12. IYY. See, this way. Outer depth into outer width cube by 12 minus empty depth into empty width cube divided by 12. That's all. Make a note. Okay, now I will give examples for you. Okay. See, this one, no x bar, y bar. First I will give example. Now this will not take much time. This all same. Example 1. Example 1. Thicker, okay, that is not important. Both are same thickness. It can be different. See, okay, no problem. See here. This is, see, this width is 250. Total depth is 400. This thickness is, this is a hollow rectangle section. This thickness is 12. This also 12. This is 10. This also 10. Start. Directly, without any calculation. See how fast you can do it. Outer width, how much? 250. Outer depth, 400. Mark it. Then 12. Okay. Okay. This width you require. How much? 250 minus 10 minus 10. 230. I put a dot here. See how I got dot? Dot is 250. That is your B dash. See that B dash. 250 minus 10 and 10. 2 into 10. And this one, I'll put double dot. That is your D dash. Double dot. 400 minus 2 into 12. 2 and 12. So 2 into 12 is 24. 376. So this is 376 right here. Of course, remember calculated value. See 250 minus 10 and 10. 230. 400 minus 12 and 12. 376 over. If you want area, see here. 250 into 400 minus 230 into 376 over. If you want, mark x, x, y, y, because you may require to mark it directly. See, y, y, x, x. 400, each half of 200, 200. This is 250, each 125, 125. 125, 120, out of scale. Okay. Now, I about xx. 250 into 400 cube by 12. Subtract 230 into 376 cube by 12. 230 into 376 cube divided by 12 over. That's all. I, y, y. See, now hold here. Y, y. 400 into 250 cube by 12. Minus, see, 376 into, minus actually, 376 into 230 cube divided by 12. Make a note, see, these two thickness need not be equal, but upper thickness should be equal lower thickness, right side thickness should be equal left side thickness. Okay, now, this over now. Example 2, I'll directly give you here one more example, further easier, see. Example 2. Hollow rectangular section, see, 125 by 300. Then thickness equal to 8 means, see, it means what? That means this is out of scale, okay, not 125. I'll put 230, okay, 230. Means this is 230, this is 300, this is 8, this also 8, this also 8, this also 8. So this question, your B equal to 230, D equal to 300, your B dash equal to 230 minus 8 and 8. 8 and 8 is 16, is 214, and D dash equal to 300 minus 8 and 8 is 16. Correct? 230 minus 16 is 230. 300 minus 16 is 284. Correct. Over. See now. Area 230 into 300. IXX 230 into 300 cube. You should write correctly 12 minus 214 into 284 cube divided 214. Okay. By 12 over IYY. This way. 300 into 230 cube by 12 minus 284 into 214 cube by 12. That's all. Answer you write. Okay, now closing part. See, in case of torsion, they can give solid circular section or hollow circular section, but there you require polar moment of inertia. It is not pi by 64, it is pi by 32, but still no problem. And in case of columns in strength of materials, so many times questions are given for a column of hollow circular section. So lastly, hollow circular section, it will be over in 2 minutes now. The last one, hollow circular section. Hollow circular section. Some people also call as pipe section or hollow cylindrical section. See, we write here directly. Let D1 be outer diameter or external diameter. D2, my symbol, is inner diameter or internal diameter. That's all. What is there? First of all, see. Hollow circle. And very neatly I am not writing. Little zigzag I am writing. Okay. See. This is D1. This is your section. See. This is D2. That's all. See. This is center. XX here, YY here. If I write distance, somebody will be laughing. Sir, we know it, sir. Okay. You write. How much? This will be D1 by 2, not D2 by 2. D1 by 2, D1 by 2. This also is D1 by 2, D1 by 2. Full outer, D1 by 2, D1 by 2. See now. Area. Pi by 4 of D1 square minus pi by 4 of D2 square, or you can tell directly area equal to pi by 4 of D1 square minus D2 square. Okay, area over. Now, your I about XX will be equal to I about YY equal to pi by 64 of D1 power 4, I of the full circle minus pi by 64 of D2 power 4, or you can tell pi by 64 of D1 power 4 minus D2 power 4. That's all. Actually not required here. Anyway, this much I have done. One numerical example. See. Example. Numerical. Hollow circular section of outer diameter 200 millimeter and thickness 12 millimeter. Okay, right. Okay, as neat as possible. Okay, now see. Outer dia 200. Thickness is 12. If thickness is 12, you see this is your D1. Inner dia is how much? See, this is D1. Remember, your inner dia D2 equal to outer dia outer dia minus 2 times thickness equal to 200 minus 2 into 12. Why? See, inner dia equal to outer dia minus thickness or equal to 24. 176. Enter here. D2 is 176 over area pi by 4 of 200 square minus 176 square. I about xx equal to I about yy equal to pi by 64. I forgot here xx by y you have to mark. Okay, mark. Remember 200, 100, 100, 100, 100. You write pi by 64 of outer dia power 4, 200 power 4 minus inner dia power 4, 176 power 4 over. I did little fast because there is nothing here. Everybody will understand. Those I section, symmetrical I section, that outer BD cube minus empty BD cube for symmetrical. Unsymmetrical, y bar required, y1, y2 required, but need not worry this minus that directly. Y bar minus y square is your h. H is y bar minus y. H1 equal to y bar minus y1. H2 equal to y bar minus y2. That you practice, you get a full grip. See, those who do not want shortcut method, they can go to old method. In the earlier class, systematically I told split by split. By each one I explained. This is actually shortcut. Okay, now go through everything. Next class we will continue question number 20. This is special class here. This is extra class for shortcut. Now series of questions will come. Okay, thank you.